Nanyang Primary Mid-Year Practice 2025. This is for paper 2, so calculators are allowed. Question 1. The bar graph below shows the number of stamps collected by 4 boys. So you're supposed to complete the table with the number of stamps collected by each boy. So the table is here. Okay, let's look at from the bar graph, right? How many stamps they each collect. For Greg, okay, so first let's look at intervals. From 0 to 20, there are 4 intervals, so each interval is a 5. Okay, so every line you count it by a plus 5. So this is 40, 45, 50. So Greg is 50. Okay, then we have Lyndon. Lyndon will be 80. Yusuf is 35. And Leon is 95. Okay, then just fill up this table. 2 of them are already filled up for you. So we have 80 here, 95 here. Question 2. A bicycle wheel of diameter 80 cm made 3 complete turns. Find the distance covered. Now, if we're looking for the number of turns, right? We're looking at the circumference of the circle. So circumference of circle is pi times diameter, and we are given the diameter. So 1 complete turn would be 3.14 times 80, which is 251.2. Now, if you have 3 complete turns, you want to multiply by 3. Okay, then you get 753.6. It's question 3. Okay, for question 3, Mr. Tan bought a laptop. The price of the laptop before GST was $2,580. He had to pay GST of 9% on the price of the laptop. So what's the amount of GST he had to pay? Now take note, we're not looking for how much he has to pay in total, but just the GST. If the price of the laptop before GST was $2,580, then that is 100% of the original. Okay, so 2,580 is 100%. What we're trying to find is just 9%. You can do the unitary method where you find 1% and then you find 9%. Or you can find 9% straight by taking 9 over 100 times 2,580, which is $232.20. Question 4. A machine started printing brochures at 8 a.m. on Wednesday at a rate of 800 brochures per hour. After every 5 hours of printing, it would be stopped for an hour to cool down. How many brochures were printed by 6 a.m. the next day? Okay, so we started at 8 a.m. on Wednesday, and then we're looking at until 6 a.m. the next day, which is Thursday. So let's find out how many hours that is first. So 8 a.m. on a Wednesday. Okay, let's go to the start of Thursday, which is 12 a.m. So 8 a.m. to 12 a.m. and then from 12 a.m. we go to 6 a.m. on Thursday, the end time. So this is 16 hours because 8 to 12 p.m. is 4 hours and then 12 to 12 is another 12. So 4 and 12 makes 16. So 16 hours. Then from 12 a.m. to 6 a.m. is another 6 hours. Okay, so this is 16 hours plus 6 hours, which is 22 hours. So the total time taken is 22 hours. Now for every 5 hours of printing, it will stop for 1 hour to cool down. So we will do grouping where we group 5 hours of printing. Okay, so 5 hours print, then 1 hour cool down. Okay, cool down. This is one group. So in one group, we have 6 hours, number of groups. We would take 22, divide by 6. This will give us 3, remainder 4. Okay, 3 remainder 4 hours. So how many brochures were being printed in 3 groups of 5 hours? If every hour you can print 800, right? So in one group, okay, in one group, 5 hours would be 5 times 800, which is 4,000 brochures, right? So if we have not 5 groups, 3 groups. If we have 3 groups, this will be 3 times 4,000, which is 12,000. Then we have that remainder of 4 hours. Okay, remainder of 4 hours. 4 times 4,000. So this 4 times, not 4,000. 4 hours times 800. Sorry, 800 brochures. This is 3,200. Now we add them up. Okay, so 12,000 plus 3,200, which is 15,200. Okay, sorry. Alternatively, you can also do it where you have 3 groups remainder 4, right? From this step, 3 groups remainder 4. 3 groups will be 3 times 5 hours of printing. So I'm actually finding total time. 3 times 5 hour of printing plus your remainder of 4 hours. This will give us a total of 19 hours of printing. Then we just take 19 times 800. This will also give us this answer. Okay. So this one is finding the brochures in a group before I find 3 groups. This one is finding the hours, time taken. Then I take the total time taken, multiply by the brochure per hour. Either way is fine. Okay, let's look at question 5. Question 5 is on average. Kendrick bought 4 different storybooks. The first storybook cost $14. The average of the remaining storybooks was 3/7 the cost of the first storybook. So how much did he pay for all? Okay, so the first storybook is 14. The first storybook, $14. Average of the remaining. Okay, so we find average of remaining books. Okay, so average is if they were to split equally, right? So average is like as if when you split equally, what is the cost of each book? So that's one book. 3/7 of $14. This will give us $6. So if they were to split the cost equally, each book will cost $6. Now, there are four books, right? The first book is 14. So the remaining books is talking about the remaining three books. So we take 6 times 3, which is 18. Then we add back the first storybook, which is 14. So answer $32. Question 6. The figure is made up of a rectangle and a triangle overlapping each other as shown. 1/4 of the rectangle and 2/5 of the triangle is unshaded. Area of the unshaded part is 57 square cm. Okay, so find the area of the rectangle. Now, 1/4 of the rectangle is unshaded, and the unshaded part is this. Okay, so 1/4 of the rectangle is actually 57 square cm, which means that the rectangle would then be 57 times 4. Okay, so answer 228 square cm. B, what fraction of the figure is unshaded? So we're looking at this overlapping part. Now I can use equivalent proportion here. So equivalent proportion means we have a fraction of something equals a fraction of something else. So in the diagram, right, I know the unshaded part of the triangle is the same as the unshaded part of the rectangle. So I can write 1/4 of the rectangle, since they said 1/4 is unshaded, is equal to 2/5 of the triangle, because they said that 2/5 of the triangle is unshaded. Okay, then we find common numerator. In equivalent proportion, you always make numerator the same. So now I can say that this 2 units of the rectangle is equal to 2 units of the triangle, and they're referring to the unshaded part. So this unshaded part here is 2 units. So the whole rectangle to the whole triangle is 8 to 5. And the shaded part of the rectangle would be 8 units minus 2 units. Okay, so the shaded part of the rectangle is 6 units. And the shaded part of the triangle would be 5 units minus 2 units. So this is 3 units. What fraction is unshaded? The whole figure is 6 plus 2 plus 3. So 6, 2, and 3 gives us 11 units. So the unshaded part is 2 units, right? So your answer would be 2/11. Question 7. In the figure below, PQRS is a rectangle, QRT is a right angled triangle as shown, with sides measuring 30, 40, and 50 cm. Perimeter of the shaded part is 174 cm, What is the ratio of the area of the triangle to the area of the shaded part? Give your answer in the simplest form. Now, area of triangle you can easily find, right? Which is half times base times height. Your base and height will be your perpendicular lines 30 and 40. Okay, the problem is the shaded part. How do you find the shaded part? To get the shaded part, I would take rectangle minus triangle to get the area of the shaded part. But to find the area of the rectangle, I would then need the breadth, right? I have the length, I need the breadth. So what we do is we use the information given, perimeter of the shaded part. Perimeter of the shaded part is 174. So 174 minus 30 minus 40 and minus 50 will give me two of the breadths. Okay, so that's two of the breadths. So 174 minus 30, 40, and 50, which is 54. Then the breadth would be 54 divided by 2. So this is 27. Okay, so now I can find area of the rectangle. Which is 50 times 27. 1350. Area of the triangle half times base times height, which is 30 and 40. 600. So the shaded part would be rectangle minus triangle. Which is 750. Now I can look for the ratio of the triangle to the shaded part. So triangle to shaded. Triangle is 600, shaded is 750. So when you simplify this ratio, you should get 4 to 5. Okay, so that's the answer. Question 8. Nurul and Pili went shopping together with a total sum of $60. Nurul spends twice as much as Pili. The amount Pili had left was $7 more than what she had spent. She had twice as much money left as Nurul. How much money did Nurul have at first? Okay, so firstly, you are given the total. Now, we know the proportion of what they spent, right? So I'm going to use a model to show that first. I'll slowly put in more information, but firstly, Nurul spent twice as much as Peli. Okay, so this shows what they spent. Spent. Then amount that Peli had left was $7 more than what she had spent. So whatever she spent, right, is this one big unit. Now what's left for her is $7 more than one big unit. So you have to add. Okay, maybe I use another color. One big unit plus $7. Okay, I'm assuming that 7 is a big one. It's easier to cut later. Okay, so this is what is left for Peli. She had twice as much money left as Nurul. So for the amount that Nurul is left with is actually half of Paylee. So what I'm going to do is I'm going to cut this unit into half and I'm going to take half of $7. Okay, so half of 7 is 350. So what Nurul has left is one small unit plus 350. This is left. So to make it easier to see, I'm going to label U for the units. And then for the amount spent, I'm also going to cut them equally. So that our units are all the same size. Okay, like that. So that total, everything together is $60 at first. So what can we do? So $60 minus $7 and 350, that will give us 5 plus 4, so 9 units. $60 minus 7 minus 350, that is 49.50. 49.50, so 1 unit, 49.5 divided by 9, which is 550, 5.5. How much did Nurul have at first? Nurul had 5 units plus 350. So 5 units is 5.5 times 5, which is 27.5, then plus 350. So answer $31. Okay, Nurul had $31 at first. Okay, question number 9. 9 is I would say the hardest question here. Uh, okay, Susie formed a solid using some 2 cm, 3 cm, and 5 cm cubes. She used a total of 18 cubes to form the solid. The total volume of the solid was 707 cubic cm. How many 2 cm cubes did Susie use? Okay, with this, for this question, I'll bring you to the slides for explanation. Hold on. Okay, now take a look at this question. Question 9. Um, so firstly, there are two methods. I'll go through two methods, but I would think the first method is probably more efficient. Might be a bit hard to understand, so just listen. Firstly, you have 2 cm cubes, 3 cm cubes, and 5 cm cubes, right? This means that every side is either 2, 3, or 5 cm. Now, since we're looking at the total volume, 707, let's find the volume of each of the cube. So the first one is 8 cubic cm. then we have 27 and 125 cubic cm. Okay, so we need to find a way to get all these combinations of 8, 27, and 125 such that it adds up to 707. And also take note that there are a total of 18 cubes. Okay, so firstly, I want to eliminate. This is somewhat like there are three different variables now, right? Three different cubes. What I want to do is to remove one of them first. Okay, so I know that the size of every cube is at least 8 cubic cm, right? It has at least 8 cubic cm in each of them. So when I remove 8 cubic cm from all the cubes, right? There are 18 cubes. I would I would eliminate this cube. I mean, all your 2 cm cubes will be gone. Okay? So 18 times 18 times 8 first, you get 144. So I'm basically, again, I'm removing 8 cubic cm from every cube, which means that my 2 cm cube would disappear. Okay, it would be removed. So 707 minus 144. So 8 minus 8 becomes 0. This will be gone. For the 27 cubic cm, if you take away 8, you're left with 19. So every remaining cube will have a volume of 19 square cm. The extra volume lah, okay? I'm not saying that the cube is 19 square cm, but the extra volume after removing 8 cubic cm. Then the last one, you're left with 117. Okay, so now you're only comparing between this 19 and 117, which will give us a total volume of 563. So 563 first. Okay, so 563 will be a total volume of all these, right? And I don't know how many cubes there are. 18 is everything, including your first 2 cm cubes. But I've already removed them. But I'm not sure how many I removed. So let's start off with how many 5 cm cubes can there be? So we take 563, divide by 117. The most you can go is 4 cubes of this. Now your remainder must be a multiple of 19. Okay, because your remainder has to be made up of 19s. It's either 117s or 19s. So let's check 95. 95 can we divide by 19? So 95 divided by 19, yes, we can divide by 19. It gives us exactly 5. So we know that there's actually 5 of that. Okay, 4 of this and 5 of this. So since the total was 18, then the number of 2 cm cubes will be 18 minus 5 and 4. So answer 9. Okay, this is the first method where you don't really have to guess and check for all 3 cubes. Okay, you eliminate one of them first so that you have lesser to work with. Now, method 2 is your guess and check method. So you find the volume of each of them. Now, what I'm going to do is I'm going to list down, because I don't know what combinations it is, right? So I'm going to list down like one of each, 2 of each, 3 of each, and so on. So for 2 cm cube is multiples of 8. This is just a table with data that I'm supposed to look at and form 707. Okay, our 3 cm cube will be multiples of 27. Then our last one will be multiples of 125. Take note, I'm stopping here because anything bigger, it would be too much. The total is only 707. Okay, so from here, I basically pick 3 numbers from each column to give me 707. Okay, and actually these are the 3 numbers. So using guess and check, you have to work with three different variables, and you have to kind of make a guess like which 3 will actually give you 707. Okay, so that's the difficult part about using guess and check when there are 3 different variables in the question. So from here, the answer would be 9. Yeah, 2 cm cube would be 9. Now, question 10. Following diagram shows a piece of paper QRST in the shape of a trapezium. You have 115 degrees here. Paper is folded along the line UV, which is parallel to QT. Okay, so you're supposed to find angle X for part A. Angle X is over here. Now, using angles at a point, if you can remove this angle here, you basically get angle X. So what is this angle here? If we have the trapezium before it's folded, right? It would look something like that. Basically what you have in the first diagram. So this angle here is actually the same as this angle here. So that is 115. Okay, so angle X would be 360 degrees minus 115 degrees. So answer 245 degrees. Next, for part B, you're supposed to find angle Y. Angle Y is over here. This angle here and this angle here, when it's folded, it's equal. So here, this one and this one. So since you have parallel lines, angle QUV, okay, QUV, this one, will be 180 minus 115, interior angles, the one that looks like U. Okay, they add up to 180. So angle QUV is 180 minus 115, which is 65 degrees. Okay, so this is 65. This is 65. This is 65. So angle Y, angles on a straight line, 180 minus 65 minus 65. Which is 50 degrees. So angle Y is 50 degrees. Question 11. In a figure below, EFGH is a square. You have 116 degrees here. EF equals to EJ, so isosceles triangles. Then you have straight lines, FKH and JKE. Find angle KFJ. Okay, KFJ is over here. Okay, so firstly, I want to find angle FEJ because I have a square. The diagonal cuts it into half. This is 45 degrees, so I can find FEJ first. So to find this, sorry, that is 45. Okay, let me write here angle FE FEJ is 180 minus 45 and 106, which is 29 degrees. Okay, this is 29. So since I have isosceles triangle, right? Isosceles triangle means that I can find this angle here, EFJ. So angle EFJ would be 180 minus 29, then divide that by 2 for the base angles. So 75.5 EFJ, then you just minus off 45 degrees. Okay, so angle, last step, angle KFJ, 75.5 degrees minus 45, 30.5 degrees. Question 12. At first, Lisa had a total of 66 blue and pink balloons, 17 pink bursts. She then increased the number of blue by 75%. After that, she had a total of 79 balloons. How many pink did she have at first? Okay, so you have, there's total of 66 at first. 66 at first, then we have 17 of the pink that burst. Let's find out how many balloons were left after the pink had burst. Okay, so 66 minus 17. Then you're left with 49. So this 49 is the pink in the end and the blue at first. Okay, pink in the end, blue at first. Pink, okay, pink after plus blue at first. Now this 79 is pink after, blue after. So the difference between the 79 and 49 is actually the change in the blue. Okay, it's a change in the blue. The increase in the blue. So the increase in blue is 79 minus 49, which is 30. Now they mentioned that the blue increased by 75%. So 75% blue is 30. Now, I want to find, what do I want to find? I want to find pink at first. So let's find blue at first. 100%. I need 100% of the blue. Or you can go 1% or you can do 25%. So to get 25%, I divide by 3, which is a 10. Then I want to go 100%. I times 4. So blue at first is 40. There's a total of 66 at first. So 66 minus the blue, you get the pink at first, which is 26. Okay, so 66 at first minus away the blue at first, you'll get the pink at first, which is what we want. Question 13. A rectangular tank with a base area of 3,500 square cm and a height of 80 cm was 1/4 filled with water at first. At 8 a.m., a tap was turned on and water was drained from the tank at a rate of 4 liters per minute. So at 8:06 a.m., the tap was turned off. Part A, how much was drained from the tank? So from 8 a.m. to 8:06, that's 6 minutes. Every minute, you have 4 liters being drained. So we take 4 times 6. 4 liters times 6 minutes. So 24 liters. Okay, so at first it's 1/4 filled with water. And then you have 24 liters being drained. After the tap was turned off, how much more water was needed to fill the tank completely? Okay, so the tank can hold, we need to find how much can the tank hold. Okay, then after that we'll find what is the volume in the end. Then we find the difference to find how much more water is needed. Okay, so capacity of the tank is base area times height. This is what the tank can hold. Capacity of the tank is 3500 times the height, which is 80. 280123. Okay, this is in cubic cm. Let's change this to liters. So to change the liters, you divide by 1,000. So this is 280 liters. Now we have 1/4 of it filled. Only 1/4. So volume at first, 1/4 times 280 liters, which is 70 liters. Okay, 1/4 because they said that it's 1/4 filled at first. Now, if there's 70 liters of water at first, and then you have 24 liters drained out, right? So the volume in the end, or volume after, is 70 minus 24. Because 24 liters was drained. This gives us 46 liters. How much more needed to fill the tank completely? The tank can hold 280, but now you only have 46. So how much do you need? You take 280 minus 46. Okay, so answer 234 liters. Question 14. Okay, this question is interesting. We have 6 identical rectangular boxes that can be stacked into a cupboard 0.9 meters wide. So 2 arrangements are shown. This arrangement shows a 42 cm gap at the top. Second one shows a 10 cm gap at the top. Okay, and another gap at the side. So in the arrangement shown in this, right, what's the width of the gap? So the width of the gap would be the difference between 2 breadths and 1 length. Okay, 2 breadths, or like 0.9. 0.9 minus 1 length. Okay, so 0.9 is 2 breadths, right? So one of the breadth here would be 9, okay, 1b. 90 divided by 245, which means that this is 45. Okay, what I'm going to do is I'm going to compare this, because if you compare the length of the cupboard, right, on both, you notice that they both have 1 length. Like they both have 1 length here, right? So the only thing different is this part in green and this part in green. How it's arranged is different, but the total length is the same. So 45 times 4 plus 10 is the same as 2 lengths plus 42. So let's find this part here first. Okay, 45 times 4 plus 10. Okay, let's just do straight. 45 times 4 plus 10. Which is 190. So this part here highlighted in green is 190, which means that this part here highlighted in green is also 190. So 190 minus 42, then you divide by 2 to get 1 length. So 190 minus 42, then we divide by 2 to get 1 length. So 1 length. 148 divided by 2, which is 74. So this part here is 74. Okay, because this is 74. So 90, the gap, sorry, no. This is not 74. That's the breadth. 74 is over here, the length. Okay, so that's 74. So 90 minus 74. 16. So the width of that gap is 16 cm. Now, part B, what's the height of the cupboard in meters? So now we have all the measurements we need. You just need to take 74 times 3 plus 42. Okay, 74 times 3 plus 42. 222 plus 42, 264. In meters, so this is cm, convert it to meters, 2.64 meters. Okay, so 2.64 meters. Question 15. Carl had clips of 4 different colors. 1/8 of the clips were white, 2/7 of the remaining clips were red. He had an equal number of blue and yellow clips. Carl had 35 blue clips. Okay, let's use a model. Now take note, this is 2/7 of the remaining. Okay, so when we draw, you should draw 8 units first. So 1/8 were white. Okay, so this is white. Now you want 2/7 of the remaining, and the remainder has 7 units, right? So you don't need to cut it further. Just 2 units of that would be for red, and then the rest will be blue and yellow. Now they said that there's equal number of blue and yellow, 35 blue. So blue and yellow would be 35 times 2. So that's 5 units. One unit is 14. We're looking for red. Red is 2 units. So 2 times 14, which is 28. Okay, so answer 28. Part B, Carl packed all the blue clips into small, medium, and large boxes. He filled each small with 2 clips, each medium with 3, and each large with 6. All the boxes were full and there were no clips left over. So what's the least number of boxes used by Carl? Okay, we're looking at only blue. So blue, you have 35 as given in the question. So 35, how are you gonna split them into small, medium, and large boxes? Okay, you want the least number of boxes. So firstly, this is 35. You want the least number of boxes, which means that you want as many large as possible. Okay, as many large as possible. So if you have 35, what's the maximum number of large boxes you can have? Every large, you can have 6. So firstly, 35 divided by 6. Okay, nothing more than 5. 5 is the biggest number of large. But if you put them into large, right, then the remainder will be the number of clips that goes into your small and medium boxes. Small is 2, medium is 3. Remainder is 5. So you can split it into one small plus one medium, right? So this is 2 plus 3, which will give us 5. So total, how many boxes are there? Big boxes, 5. One small and one medium. So total, okay, this will be 2 boxes. Not 5 boxes, but 2 boxes. One small, one medium. So 5 plus 2 equals 7. Okay, so is this 5 plus 2. So answer 7 boxes. Question 16. A symmetric figure is drawn on a rectangular piece of paper, 20 cm by 15 cm as shown. Its outline consists of 2 large semicircles and 2 smaller semicircles and 2 straight lines. Now, it's not clearly shown here, but it should look something like that. So you have the big semicircle on top, and then one large semicircle, 2 smaller semicircles, and 2 straight lines. So these are the straight lines, this part here and this part here. Okay, what's the area of the figure? Now, to find the area of the figure, it's actually big semicircle plus this rectangle here, then minus the two smaller semicircles. Okay, so the parts that you need to find that is related to circles will be your big semicircle and your small semicircles, right? So let's find that first. To find area of circles, you need pi times radius times radius. So you need the radius of the big semicircle and the small semicircle. The big semicircle radius would be 20 divided by 2. Okay, so 20 divided by 2, which is 10. Okay, then because this is 10, this is the diameter of the small one, right? So the radius of the smaller semicircle is 10 divided by 2, which is 5. Now let's find the area of the semicircles. The big semicircle, half times pi, 3.14, times radius, which is 10, times 10. This will give us 157. Next, the small semicircle, half times pi, times 5 times 5, which is 39.25. Now, big semicircle plus this rectangle minus the 2 small semicircles. The rectangle is, okay. So, this line here, you need to find this line in order to find this. Oh no, actually you can use, this is the radius, right? This is radius, which is 5. So this is 5. So you can take 5 times 20 for the rectangle, which is 100. Okay, 20 is the length, 5 is the breadth. Rectangle. So big semicircle plus rectangle, then minus the two semicircles, two smaller semicircles, so 2 times 39.25. This will give us 178.5. In your shaded part is 178.5 square cm. Now for part B, what is its perimeter? So what is the perimeter made up of? We have this arc here, okay, of the semicircle, the big semicircle. Then we also have the arcs of the small semicircles. Okay, then after that, we have two straight lines. So you need to add all of that. Circumference is half, pi times diameter. So to find the green one, semicircle, half times pi times diameter. So half times pi times diameter. Big semicircle is a 20. So 31.4. The small one, diameter is a 10. Okay, so let's find 1 first. So half times pi times 10, 15.7. Now we add all of them up, including the straight lines. So 2 times of 15.7, then there are 2 fives. 2 fives, the pink lines. This will give us 72.8 cm. Question 17. Okay, the amount of money Kathy had to the amount of money Alice had was 3 to 4. After Kathy spent 250 on a bag and gave 50 to Alice, the ratio became 1 to 2. How much did Alice have at first? Okay, I'm going to show you using the model method. You can use your units and parts method, but I'm going to show you model, how it's done using model. Okay, so firstly, what they have, K and A. K has 3 units, so 3 to 4, so 3 units here. Alice, 4 units. Kathy spent $250 and gave 50 to Alice. And then in the end, the ratio became 1 to 2. So firstly, let's look at what Kathy lost. Kathy spent 250, right? And also gave away $50. So the total amount removed is actually 250 plus 50. Okay, 300. So let's remove 300 first. Now, what about Alice? Alice received 50 from Kathy, so let's add a 50. Now, whatever that is left, Kathy is supposed to be, the ratio became 1 to 2. So Kathy is supposed to be 1 unit, and Alice is supposed to be twice of that. Okay, look at what Kathy is left with. You have 2 big units and 1 small part. So Alice is supposed to be twice of that. 2 times of K. Okay, so what is 2 times of K? This part here, 2 times of K in the end. So if this is 2 times of K in the end, right? K has 2 units, A has 4 units. So that's 2 times of the units. But this 50 is 2 times of this part here. So what is this part? What's the value of this part? So if that's 2 times means that if I were to cut this into half, this would be 25 and 25, right? So this is actually 25. Okay, now you compare. A has 2 times of K in the end. K has 2U plus 25, so A has 4U plus 50. So this 25 is derived from here, because I know A has twice of K. So now you can easily see what 1 unit is. Okay, 1 unit is 300 plus 25. One unit, 300 plus 25. How much did A have at first? That is 4 units without the 50, because that was given after that. So times 4, $1,300. Part B, how much did Kathy have in the end? In the end, Kathy is 2 units plus 25. 2 units plus 25. 2 times 325, 650. 650 plus 25 equals 675. Okay, so answer $675 for part B. Okay, so K in the end, 2 units plus 25. Do not add the 300 because that is part of what she had at first. We're looking for in the end. Okay, so with that, this is the last question of the paper. That's all.